All right, Sasha, we're just going to talk through a little bit of why we built Secret Receive together over the last 2 weeks and why 2 weeks? How did we pick that number? Why ship software in a 2 week increment?
Well, I mean, the first thing is, part of our big pitch is that we want to be able to test ideas, right? We want to be able to get something out into the market, see if it works, get feedback, iterate from there. And 2 weeks seemed like a reasonable amount of time for building something, essentially prototype, proof of concept, getting it out to market, trying it out, getting feedback.
Yeah, exactly. I mean, the comparison often from if you're at a bigger company, like some of our background, if you're going to really build something, it's going to be like a planning process, and then there's going to be a couple different milestone markers, and it's like a 3 month thing to ship something or a 6 month thing. And in the meantime, the market's changing, competitors are moving, you haven't talked to customers, et cetera, et cetera. So this is not, I mean, we have the name semi decent for a reason. It's not because we think that software should be substandard. It's because the goal is to get stuff out quickly to get customer feedback. So we've already shared this with folks, but what is it, Sasha? What did we build? What does Secret Receive?
Yeah, I mean, the basic premise is just to be able to securely receive files from another party. So we sort of flipped the typical idea of let me send you something securely and kind of flipped it on its head and said, well, let me send you a link, a really just easy to use, no software downloads, no account creation. We'll just send you a link. You can upload files. The files are end-to-end encrypted, so only I, as the receiver, can decrypt them. And then, yeah, it's just a super simple way to receive files from somebody else.
This is a little bit of how we tested locally, actually. The receiver, the person who sets up the vault, can see inside the vault and share this link so that people can add files. It's all happening in the browser. We didn't build a Mac OS app or, there's nothing to install. It's all browser APIs.
And this is part of the 2 week thing, right? Is
Yeah.
we liberally decided to cut user management, user accounts, all that kind of stuff. Because that was one thing, we talked about early on, which is, okay, do we want to have, user accounts, organizations, all the stuff that you would normally need for a product to be able to sell it. But in our case, we said none of that is necessary to prove a concept. We just want to be able to do it all in browser and to have it go as seamlessly as possible.
Part of the idea of the 2 week block is not, this is how we work with clients, is that we don't just sit down and say, okay, well, we're going to just see what we can build in 2 weeks. The whole point is to have a very clear, crisp understanding of what are we building and what are we not building, right? So we started with a blank repo, right? There was nothing.
Right.
And we outlined, the pages and the affordances, or what you can do on each of those pages, the actions. And we outlined the tech stack a little bit. And then we also talked about what was out of scope. And we actually ended up adding some of these because we were ahead of schedule, right? Which is pretty great. For example, we originally said you can only have one file per vault. There was a file limit, a file size limit. But we did say like desktop browser is the demo. Well, how is this different than a sprint, right? We've both worked in Scrum and Agile environments. This Miro board represents what's in and out of scope and what we're building. And we moved as necessary, but how does that differ in some of the other project management systems that you've worked in at other places?
I think the main difference that I see is that we are really just ultra focused on the end goal. What is the deliverable at the end of the 2 weeks?
Yeah.
Right. Sprints people tend to get tied up, in project management, especially the bigger the company is. I think this is more true, but people get tied up in the, how many points are we allocating? What's the sort of minutia that everyone's doing, right? Like what are the individual little ticket level items that people have? And for us, it's what is the deliverable? That's really all that matters. So we have a deliverable. We know that we're delivering this proof of concept, this prototype in 2 weeks. And then we're working backwards from there to figure out what we can do. So as you mentioned, we actually hit some of our stretch goals of the multiple files per vault and things like that. But conversely, we had to cut like the Backblaze B2 integration because we just decided, it was not going to be worth the amount of time that we spend on it because it doesn't actually add any functionality for the end user.
Yeah.
So things like that, it's like we can more aggressively cut things that aren't needed, and we can prioritize, as opposed to sprint, which generally the way most companies implement it is pretty locked down once it's started.
Yeah, that's right. I mean, it's like you kind of agree, like, this is your sprint commitment, and our commitment is to what the user is going to be able to do at the end of the 2 week sprint. This is live on the internet, I suppose, right? I mean, let's add a file real quick, right? Because I just took a screenshot yesterday. I guess I don't know what it is, but this uploads to the vault that was shared with us, right? So this sender doesn't have a vault. They only they had the link to a vault that was shared with them. But then, here it is, this example demo vault. This is the file. And so we agreed by removing the Backblaze integration, or like deferring, we deferred it. It's not that we removed working code. We said, what is the real priority? It's to be able to send files, which we just did. And this is not a way to scale to 1,000 users. But that's not actually the essential question that we're trying to answer and get feedback on, because we have no users. We have people that we're getting feedback from, real users, and they don't care if it's Backblaze. What is it, Sasha? Tell us more about the back end.
We're using Svelte JS on the front end, just a really kind of light framework alternative to React. FastAPI Python on the back end. And so for file storage, we're just using the local file system right now because it's the fastest way to get started. We can just upload files to directory on the actual EC2 instance. So it's all hosted in AWS. Just a really, really simple, no frills sort of architecture. But again, it was the fastest way to get something out the door. We don't have to mess with, Kubernetes pods and Terraform and all these other complex technologies and try to get them to work and, have redundancy and all this other stuff that we just don't need. We can just put it on an instance, point the domain to it, and basically call it a day.
The goal from here is we're getting feedback from folks, and then we could add that, right? The next 2 week block that we build could be to add Backblaze support, or it could be to whatever actually adds value to users, or just to be plain about it, like the feedback could include, this is not useful, go back to the drawing board. And we've only, like, our sunk cost is only this 2 week block instead of crickets after a 6 month build out.
Well, and that's the beauty of, whether it's 2 weeks or 6 weeks, but it's still a lot less time than you'd spend building out this whole product, right? If you were, trying to raise money or something like that, you could spend months building this out. And for us, the idea was just, let's test it out, let's get feedback, and then the next block will incorporate that feedback that we receive from users. So, we could decide, okay, we're going to do the short 2 week block just to get the prototype out. And, maybe our assumptions don't hold. Maybe the receive part is not what people want. People actually do want to be able to send files. Or, maybe some other assumption. Doesn't really matter. But the point is, we test it and we pivot from there, and maybe our next block goes in a different direction. So maybe next one is 6 weeks, but we have a clear idea of what we're building. And so we don't put our heads down and build the wrong thing for 6 months and nobody wants it.
Yeah, that's exactly it. It's better to be 80% right at the right time than 100% right too late. So we don't want to build the wrong thing. The software is typically not necessarily the hard part. It's, what do people want to do? How do people want to use it? Let's talk about some of the encryption stuff.
Yeah, so the encryption, I think, is a great example of our philosophy, our 2 week block in action, because, we wanted to deliver something that, that does the job, right? That encrypts files, that sends them securely. And end-to-end encryption was a goal we had in mind from the beginning, because it is a differentiator from other products, right? Like if you upload something to Dropbox and Dropbox gets hacked, the hackers will have access to that file. And so that's fine. Like for most things, that's okay. But there is a subset of, documents of information where you just cannot afford for that to leak. It could be financial data. It could be, sensitive customer information, health information. There are a lot of different categories of things that fit under this. But we wanted something that really, truly was end-to-end encrypted, so that even the service can't read it. Like if I SSH into the box right now, I can't open any of the files that anybody's uploaded.
Yeah, that's right. It's encrypted in flight, but it's also encrypted at rest, right? And we as a service, secret receive, the service doesn't hold the keys to decrypt the files. Maybe let's add the caveat of some limitations with that method in that right now only the person who creates the vault has the keys, and that's it. It's just in the local storage of their browser, right? There's because we don't have user management at this stage, but it works to test the idea out with people.
Yeah, exactly. We take the private key and put it in local storage on that device. And it's one of those things where user management would be critical if you were actually trying to sell this to an enterprise. But for the purposes of testing the idea, just kind of the one-to-one mapping works really, really well, and allows us to get it out the door faster. And I mean, one of the challenges of software projects is you don't know what you don't know. So we knew crypto would be a challenge.
I feel like reading the docs for the subtle API. Crypto.subtle is the API here for the browser. There are some subtle nuances. You're understating it quite a bit, I think.
Yeah.
It's complicated.
But the main, I think, takeaway, so we spent, I think, collectively hours, probably over a dozen hours, probably just, learning and playing with this stuff.
I mean, this is the hard part of the 2-week block, actually. I think if we're going to use the name from the API, it's subtle. The hard part of putting up a web page with a couple buttons is actually not, that's not the hard part, right? Svelte and the other front end tools that we used, I mean, you could just put up pages that don't do anything. To be clear, that is one other alternative to get user feedback, is we could just sort of, this could be just literally like a demo that doesn't really do anything, and we could get feedback that way. That's another option for doing this sort of user testing. But we wanted to actually, the difference between a 1-week demo build and a 2-week real working software, I think it's worth it. We wanted to know about what's possible with the crypto APIs, because that is the essential, like, can we actually even support this use case, was a big part of the central question, I think, right?
Yep, exactly. And it was, we wanted to do it in a way that actually holds true to that. Like that, this is one of the things that's difficult, right? Is users aren't going to know what encryption algorithm we used or anything like that. But it is pretty critical that, we wanted to go into the server and make sure that, hey, the files are actually encrypted. We can't try to decrypt them using some random key or something like that. Like just to kind of go through the steps to make sure that, yes, this is doing what we promised it would do.
Yeah.
And it's just a lot of, the other thing is, I think you asked about how this is different than a sprint. I think typically companies would reserve a sprint just to do sort of a POC of encryption, let's say.
Yeah.
And, and sort of investigate the different, it would just be kind of an investigation ticket, I think, is how a lot of companies would frame this.
Yeah.
And so, people would spend time just reading about, encryption and different algorithms and, what to do in what cases. And for us, it was, let's try this out, let's write some code. And I think we went through 3 iterations of different forms of encryption before we landed on the correct one.
Subtle really is, I'm coming back to it, but subtle really is the right term, because the Mozilla MDN docs are fine, but they're not exhaustive in their descriptions, and you really have to use them. And from my experience at other companies, it would have been like a technical design document or something, right? You'd have this big Google Doc that's potentially, depending on the exhaustive nature of it, right? You could spend a week or two writing up a 10 to 15 page document of like, well, I read these articles about these algorithms and why we should do this. And, it's a fine, I guess we are critiquing it. We think this is a better way to work. It's a fine way to do it potentially, but the challenge is that you're kind of off in like a monastic research project. And the challenge is actually like, use the thing, build the thing, build, measure, learn is a big part of our ethos.
Well, it's all trade-offs, right? Like,
sure,
we're not saying the our way is better for every single type of project. It's more that if you're trying to prove a concept, you want to get it out to market as quickly as possible. You want to get it in the hands of actual users, start getting feedback.
Yeah.
You don't really have time to spend 2 weeks on a document, right? Like, that's the whole premise for us, is it's that time to market. It's, get feedback as quickly as possible. It's that 80% right,
Yeah.
at the right time.
Yeah, I mean, no customer is going to read your technical design document is another way to kind of say it, right?
Yeah.
The proof is in the pudding. I don't know I don't know how many idioms we want to use here, but just the idea that your pretty diagrams they can be useful when you're building in a big team. I think that's the other thing to say is that it was the two of us for 2 weeks. This was not a team of 10. It's two engineers, heads down, focused on one thing, and so we paired for a lot of this or much of this. So there isn't a need to like leave a bunch of residual documentation, although we did, there is documentation, thankfully, but we didn't have to build a lot of these artifacts that you might need in a big company or on a big team to really like educate an outsider who wasn't working on the project, who might pick it up in 3 years or something.
Since I never actually answered the original question, I'll talk briefly about the
Yeah.
encryption. So after a lot of trial and error, what we learned about encryption, we started, I think both had to do a deep dive into security and all the different use cases, edge cases, things that can arise with different encryption methods and some of the attacks on these methods and what's the safest way to do things. And so the ultimate architecture that we settled on is the receiver creates an asymmetric key pair, so a public-private key pair. People who know what like GPG is, or this is used widely in SSL, right? Like TLS certificates, all that kind of stuff. That it's widely used in a lot of those circumstances. So the idea is the public key can only encrypt, and then the private key is what can decrypt. So the private key is what reads the data. So they create a key pair that contains both. They store the private key in their browser's local storage. So it basically never leaves the device. It doesn't get sent to the server, it doesn't get sent to the sender, nothing like that. And then the public key gets sent to the server because it's not as a secret. It can be shared publicly. That's sent to the server, which is then sent to anybody who opens that link. And so anybody who opens the vault link can then upload files. So then the sender actually creates, this is the part that we had to iterate quite a bit on, is they create a symmetric key using this AES GCM algorithm. And that key is what actually encrypts the data. And the reason we have to do that is because the public-private key combo, so the public key is really only meant to encrypt small data. And you can do it in a loop. You can encrypt a big file in blocks, but it's super slow. I mean, we tested it. I think, 5 meg files took like 5 seconds or something to decrypt.
Yeah.
If I remember correctly.
It saturated the processor, or at least the process for the browser.
And so, we realized that's not, on top of just being not acceptably performant in our eyes, the other problem is that, because you're encrypting in blocks, an attacker who gets access to a file could see patterns in the file and be able to deduce information about the file because they see duplicate blocks or something like that, which is just, the whole point of this is we want, even if we get hacked, nobody gets anything useful, right? That's the whole premise of this. And so the idea is that the sender will create a symmetric key on their machine. They'll use that to encrypt all of the files, and they'll use the public key to then encrypt this symmetric key. So there's sort of a inception kind of thing where there's a key inside a key, but because only the receiver has the private key to be able to decode it, we can safely send that to the server because it's all encrypted. Nobody else has access. The receiver then gets this encrypted key, they can decrypt it, and then they can use the key to decrypt the files. So it's sort of a two-phase approach, but that gives us the best of both worlds. It gives us the performance, it gives us the safety, and then it gives us the APIs to work with all this.
Yeah, I think the most useful analogy that you told me early when we were working on this, that because I've read about all this, and then the mind starts to melt a little bit sometimes when you it is like a Christopher Nolan movie. There's some mind melting that goes on, but the private key, public key part, for those who might have been lost, is like you give out locks, but you keep the key, right? Yes. The public key is you give out locks, but only you can unlock the copy of all those different locks. So that is the core aspect. Without let's throw away Inception for the mind melting part, is that only the person who has the key can open the vault, but you can give out lots of copies of the public key to put things into the vault. So that's using this RSA algorithm. But this is non-trivial I think that might be a 2-week block. That might be not immediately evident when you come here and I guess, to map it out, right? I mean, this is as the vault is created, we'll call it, I don't know, secure example. It doesn't matter what we call it. But that's where actually we can look at here in the local storage, right? That's our access token. Well, that's the access token, but there's another cookie that's set for, there it is.
Yeah, there's the private key.
Yeah, and then if we go, I guess the other way here real quick, to the person opening this vault, and let's see, that was a previous thing that we did. This is the vault. They don't have there's nothing. They don't pull down a private key. They don't pull down, they don't have any of these. They don't have any vaults they own. They don't know they do know the name from the API response.
And you were just saying, that this is a lot more complicated than the UI probably makes it seem. The other side of it too, again, unbiased here, but doing this at a bigger company would have been, like we said, there would have been the technical design documents to outline the different possible solutions and trade-offs and all that. There would have been another week or two of discussion. You would have spent another 2 weeks just building the crypto for this. It would have been a lot more steps to even get to a point where you could build a UI around it. And for us, we just had to work quickly and sort of iterate quickly and do it in actual code where we could play with it and see, okay, what are the trade-offs here? Be able to more thoroughly understand the problem space.
Yeah. And I think we've kind of made our case here for our method, but we did really start from the most essential aspect of being able to create a vault, identifying that you are the creator of the vault. So we really did start from the essential aspects of being able to create the vault, and we built from, the API, which is FastAPI was great to work with here. We did iterate as we figured out what we needed these endpoints to do. But overall, we did, for example, we didn't style these pages, not that that's a big deal, but we didn't have any styling for some of this for a big chunk of the block, the 2-week work period, because it was all about the most important parts first. Part of the idea from the shape up methodology that we're pulling from here is you want to move up the curve, up the hill, and do that, figure out those hard parts in the beginning so that you can come down the other side by the kind of midpoint of the block and coast. You've solved the kind of like unknown unknowns as best, hopefully you haven't included any of those in your scope, right? Which we tried to kind of leave out by our constraints, but you're kind of coasting into the final, which we did. Yeah. We styled and we really used this thing back and forth quite a bit and, changed copy and animated buttons and all sorts of stuff that were just sort of nice to have. Sasha, it was a great thing. And now we're getting feedback from folks.